This is part 1 of section 4.1, Polynomial Functions. We're going to spend time talking about what polynomial functions are, what they look like, what are some properties that you can gather from just looking at the polynomial function. Okay, so let's first start off with an example that kind of demonstrates what I'm talking about. Okay, so our first example here is this function f of x equals 15x squared minus 10 plus 0.11x to the fourth minus 7x to the third power. Okay, so this right here represents a polynomial function. Notice it's not that much different than a lot of the functions we've dealt with already, like quadratic functions and linear functions. Notice it has a quadratic term here, right, this 15x squared, but there are also other terms that have higher exponents, like x to the fourth and x to the third. Okay, also right here, terms that are constant, they do not have an exponent on a variable, right? There's no variable there. So in this case, by the way, if you're dealing with a constant, you would say that that's x to the 0 power that's attached to it, because there's nothing there. That's a way you could think about that. Anyway, so we have 1, 2, 3, 4 terms here. Okay, so I'm going to use that word a lot. We have 4 terms. They're usually separated by a plus or a minus, right? So you can see 15x squared minus 10 plus 0.11 x to the fourth minus 7x to the third, right? So those are 4 terms. You want to identify the term that has the highest exponent. Okay, in doing that, you're going to find most of your information here. Okay, so I look at my exponents. We said this is the second power. This is x to the 0 power. We can think about it like that. Fourth power, third power. The fourth power, excuse me, is the largest exponent here. So we would say that since this polynomial has an exponent, the highest exponent is 4, we would say that this is a degree 4 polynomial, right? It's a degree 4 polynomial. Okay, and oftentimes we'll call that a quartic function. Okay, so like a quadratic function would be dealing with x squared. Well, if your highest exponent is the 4th power, then we'd say this is a quartic function. Okay, this is a way we can classify it. Okay, some other things we can notice here. Of all the terms, the one that has that exponent of 4, right, the highest exponent, the term with the highest exponent, would be your leading term, right? This positive 0.11x to the fourth would be my leading term. Okay, and from that I can pull some information as well. Notice once you identify the leading term, you've kind of already found the degree, right? They're connected to each other. You're really looking at the same place. Also notice, this is what I'm looking at. Oop, not the minus sign. This is what I'm looking at here. Most of this stuff is irrelevant, okay, as far as what I'm trying to find out. The leading term tells you almost everything you need to know. So here's the degree, here's the leading term. There's also the leading coefficient. So maybe we should talk about what a coefficient is, and then we can say what the leading coefficient would be. Okay, a coefficient, if you don't remember, is the number that's sitting in front of an x, right, or a variable. Okay, so the number in front. So if you take the number off of it, that's the coefficient you're taking. So the coefficient for this term right here would be 15, where x squared would be the variable. Coefficient here would be positive 0.11. The coefficient here would be negative 7, and the coefficient here would be negative 10. I know we don't see an x there, but it still functions the same way. Okay, so the leading coefficient is the coefficient of the leading term. Again, I'm still looking at just this piece right here. All that other stuff doesn't help me. Okay, so there's a degree, there's a leading term, there's a leading coefficient. We said that we can classify this as a quartic function because we've identified the degree as 4. Okay, and so that's a lot of stuff right there. Something else that we can talk about, once you know the leading term, really you're looking at the leading coefficient and the degree, you can actually picture what the graph's going to look like overall, okay? The end behavior of the graph. Okay, and we'll talk more about that in a second. But I'll just say the end behavior of this graph is going to be, it goes up to the right, it does something in between, not sure, and it goes up to the left. Okay, so that's what the graph will look like. We're not so interested about what's going on in between, just the end, right? The end behavior. Okay, and we'll talk more about that in a second. Some other things I want to say real quick before I move on. Some other terms, right, to classify these functions. So if the degree, and this is for polynomials in general, is 0, we would say that we have a constant function. It's constant. If the degree is 1, it's linear. This is stuff we've dealt with before. 2 would be a quadratic. Right? We know how to deal with those as well. 3 would be cubic. Right? Like whenever you raise something to the third power, you cube it. Okay, and then 4th is quartic. And then anything higher than 4, right, 5 or higher, typically we'll just say n, representing any number bigger than 4. We'd say that's a degree n polynomial. Okay, so if this were the 5th power, we'd say degree 5 polynomial. If the highest exponent were 6, we'd say a degree 6 polynomial, and so on. Okay, so there we go. Those are the main ones, and then how we classify the rest of them. Some other things to notice about a polynomial. Look at the exponents. Positive number, positive number, positive number. 0 is not positive, but it's definitely not negative, right? So all of my exponents are going to have to be positive. That's one thing that's unique about polynomials. You don't have to worry about any negative exponents. Also notice whole number, whole number, whole number. And again, if we think about x to the 0 power, it's sort of a whole number, right? No fractions, no decimals. That's also nice, right? So polynomials are nice in the sense that they have positive whole numbers for their exponents, or at least not negative exponents. All right, so that basically is everything we need to know about that, I believe, right? We got the leading term, the leading coefficient, the degree, and we classified it as a quartic. Let's do another example. So example 2. Let's find all those things for this function here. Okay, so I put that 7/8 there to throw you off a little bit. Okay, because remember I said it has to be all positive and whole numbers, right? Well, I was talking about the exponents, right? So a number, like a coefficient or a constant term, of course, can be a fraction. Okay, but remember also, we're only looking at the leading term. So it doesn't really matter what the rest of this thing looks like. All right, so we said the degree, the leading term, the leading coefficient, and then we're going to want to classify this as, you know, is it a linear, quadratic, and so on. Okay, so the degree, we look for the highest exponent. 3. 3 is my highest exponent, so I will say this is a degree 3 polynomial. Okay, well, once I found that, I know that this is my leading term, 2.4 x to the third power. The leading coefficient is the coefficient of the leading term, right? Remember, the coefficient is the number in front of the variable, so that'd be 2.4. And I want to classify this, okay? Degree 3 is a cubic function. Okay, so that was really simple. Let's do another one. A little bit more challenging on this next one. All right, so this one's meant to be a little confusing just to make sure we got it. All right, so I'm going to write down what we're looking for. Degree, leading term, leading coefficient, and we're going to classify it. Okay, so the issue here, of course, is there's only one term, and I don't even see a variable. Okay, so remember, we can deal with that. We said earlier that if it's just a constant, you can imagine x to the 0 power is attached to it. And if you think about it that way, it's a lot easier to figure out your answers, right? Because the degree would be 0. The leading term would be negative 6 x to the 0, but of course, we don't have to write x to the 0. It's understood, just like it's understood that multiplication is always times 1 if there's nothing there. It's always understood that if there's no variable, it's that variable raised to the 0 power. Okay, so we don't put it, we know it's there. The leading coefficient, of course, is the negative 6. Right? It's the number in front of x to the 0 power if we picture it. And remember, if it is degree 0, that is called a constant function. It is constant. Okay, not so bad. Let's do another one. Okay, for the fourth example, we're going to have f of x equals 2 minus x squared. Okay, so I'm just going to write degree, leading term, leading coefficient, and our classification. Okay, so I will just abbreviate. Same thing though. All right, so highest exponent would be 2, right? X squared, so 2. Of course, that means the leading term is this piece right here, negative x squared. Be careful to remember that negative is part of it, right? It's understood this is a negative 1x squared, right? So that negative 1 is part of the term. All right, cool. The leading coefficient then, I kind of just explained that, but since it's an understood negative 1 here, the leading coefficient would be negative 1. Okay, and the degree is 2, which makes this a quadratic. Okay, another one. F of x equals 12 plus x. Okay, I just see x here, so the understood exponent is a 1, right? X to the first power, there's 1x being multiplied there. So the degree is 1. Remember, if you have a degree 1 polynomial, that's a linear function. All right, and we've dealt with linear functions before, right? Those are your lines when you graph them. Okay, leading term, of course, is positive x, right? Positive 1x to the first power, or just x. Leading coefficient, what number's sitting out in the front? It's an understood 1 out in the front, so it'd just be 1. All right, so these are not bad, right? Hopefully these are pretty easy. So let's talk about the end behavior. I did mention that earlier. I do want to talk about it. How do you predict what the graph will look like? It's a very good idea to, without having to use software or a calculator, to be able to picture a rough idea of what the graph looks like, right? And every polynomial is going to either go up this way and up that way, right? And do something in between. We don't know, but it's going to either do that, or it may go up and down and something in between. Or it may go down to the right and down to the left, right? And again, do something in between. Or it can go down to the right, up to the left, and so on, right? So that's what I mean by end behavior. I'm really interested in what's happening on the ends, not in between. Okay, and you can predict that by just looking at the leading term. Okay, the leading term will tell you all of that. So first thing to look at, and I like to use this little table, it kind of helps. Look at the leading term, but specifically at the leading coefficient. Okay, the leading coefficient. So let me write down an example to go along with this. So we're going to base this off of example 6. I want to describe the end behavior of this function, and it's intentionally ugly with lots of fractions because I want you to focus on what I'm talking about, right? So I'm telling you to look at something very specific, okay? And it does not matter if it's fractions or whole numbers or whatever. Look at the leading coefficient, and we can identify the leading coefficient as 1/4, right? It's the number in front of that 1/4 x to the fourth. Of course, the 4 being the highest exponent, so I know to focus on the 1/4 x to the fourth, and all of this is irrelevant. The leading coefficient is positive. That's what I'm looking at. Is the leading coefficient positive, or is it negative? Okay, that will tell you what the right side of the graph is doing. Okay, right side. Okay, if the leading coefficient is positive, the graph will go up to the right side. Okay, I'm doing two separate graphs here. If the leading coefficient is negative, maybe I should put this a little bit further down here. There we go. If it's negative, then it's going to go down to the right side. Okay. Now, I'm going to look at the degree. Of course, we said for polynomials, the degree is always positive numbers, right? It's always positive whole numbers. So positive and negative doesn't make sense for degree. But they're going to be either even or odd, right? So either you're going to have an even degree, like in this case, we have the 4th power, that's an even number, or we're going to have an odd degree. If the degree is even, the left side, degree tells you what happens to the left side will be the same, okay? Think about it like that. It's going to be even on the right and the left side. So degree tells you the left side. If it's even, the left side is going to do the same as the right side. It's going to be even with the right side. Okay, so if the right side goes up, the left side will go up. If the right side goes down, the left side will go down. Even makes the left side match the right side. Okay, if it's odd, think about it like this. The left side is going to be at odds with the right side. Okay, it's going to do the opposite. So O, opposite, or at odds with. So if the right side goes up, the left side will go down. If the right side goes down, the left side will go up. Okay, so that covers all 4 variations, right? You can have up, up, you can have down, down, you can have up, right, down, left, you can have down, right, up, left, right? That's your 4 variations right there. Okay, so now let's go back to our example up here. We were specifically asking about this function, 1/4 x to the fourth plus blah, 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 blah. The leading coefficient is positive. So I know I am looking at one of these two, right? Completely ruled this out. Okay, so the right side goes up. The degree is 4, which is even, not odd. It's even. So if I want to picture the graph here, it's going up to the right and up to the left. Clear all that out. And we're going to say this one here specifically goes up to the right and up to the left. Okay, and that's a visual what it's going to do. Again, it's going to do something in between, I'm not sure, but that is all I care about for in behavior. So, all right, let's do another example then. Again, I like to put the fractions there so you're not trying to do anything with them other than determine if they're positive or negative. Okay, so here's another example here. So first thing I'm going to do is find the leading term. There's my leading term, 2/5 x to the 5th. I'm going to identify the leading coefficient as either positive or negative. 2/5 is positive, So I know that my graph is going to go up to the right. Okay, always look at the leading coefficient first to determine what the right side is doing. Because remember, the left side is going to depend on what the right side is doing. All right, so now I'm looking at the degree. The degree is 5. 5 is odd. Okay, so that means the left side will be at odds with the right side. So it's not going to go up, it's going to go down. So here's the end behavior of this graph. Okay, leading coefficient first, followed by the degree. That's the order you should look at it. All right, next example, f of x equals negative x cubed plus x to the 5th minus 0.5 x to the 6th. All right, so careful with this one. Resist the temptation to say that's your leading term because it's first. No. Look at the exponent, right? The exponent, highest exponent is 6. This is my leading term. Okay, which means I'm going to focus on my leading coefficient first, negative 0.5. If the leading coefficient is negative, the right side will go down. Okay? Now, to determine the left side, look at the degree. It's even. So the left side's going to be even with the right side. It will also go down. Okay, let's do one more, and that'll be it for part 1. Okay, so the function f of x equals 2x plus x to the 3rd minus x to the 5th. Just like the last example here, my leading term is not listed first. I put it last. The degree is 5, of course, so that's why it's the highest. 5 is the highest exponent, so that's why negative x to the 5th is my leading term. The leading coefficient is this negative 1 out in the front. Most importantly, it's negative, so the right side will go down. Leading coefficient is negative, so the right side goes down. The degree is odd, right? And so an odd degree means that the left side will be at odds with the right side, and it will go up. All right, so that is it for section 4.1, part 1.